Alright guys, and this is our video covering the graphs of tan and cotan. We're going to start with the graph of tangent. Just like before, we're going to say that tangent is going to have ordered pairs made up of x values that are going to be rotations and y values that are going to be ratios defined by the x and y values where those rotations end on the unit circle. And in general, we'll say that those ratios will be the y values divided by the x values. So right here, what we're going to do first is go around the unit circle and talk about what's happening in each quarter of rotation, just like we did for the graphs of cosecant and secant. But then we're also going to go around and talk about the half quadrant rotations to get a better idea of what's happening with the graph of tangent. Right here, when we look at 0 radians of rotation, we can see that we have an x value of 1 and a y value of 0. So we would say that a y value of 0 divided by an x value of 1 gives us 0. And we actually have tangent going through the origin. Right? At a rotation of 0, we have y over x, the ratio, being 0. If we rotate to pi over 2 in 1/4 of rotation, we can say that we have an x value of 0 and a y value of 1. And that's going to give us 1 over 0 for the ratio of tan. And in general, right here, what that's going to mean, of course, just like for cosecant and for secant, is a vertical asymptote at the rotation of pi over 2. Rotating to pi radians, we can say that we have an x value of -1 and a y value of 0. And right here, that's going to give us the tan ratio as 0 divided by -1. So there again, we'll have 0. Now rotating to 3/2 pi through 3/4 of rotation here, we have again an x value of 0, and now we have a y value of -1. We can say that -1 divided by 0 is again going to give us a vertical asymptote. Right? So that vertical asymptote happens at 3/2 pi. Now right here, as we finish out a full rotation in quarters of rotation, we can say that we land back on the positive x-axis where we have an x value of 1 and a y value of 0, which gives us a 0 again, completing our period of cosine. Now we're going to go back through and talk about those quarter pi rotations, or the half quadrant rotations. One of the things that we can say in each of these half quadrant rotations is that we are going to have square root of 2 as a positive or negative for the x value and the y value, right? So right here at a rotation of pi over 4, we have an x value of square root of 2 over 2 and a y value of square root of 2 over 2. And right here for our ratio of y divided by x, we are going to get square root of 2 over 2 divided by square root of 2 over 2, giving us 1. So right here at pi over 4 radians, we are going to have an output of 1. When we rotate to 3/4 pi radians, we can see that we have an x value of negative square root of 2 over 2 and a y value of square root of 2 over 2, and that's going to give us the tan ratio as -1, since we're dividing that positive y square root of 2 over 2 by a negative x square root of 2 over 2. And right here, we can say that that's going to give us that ordered pair right there, right, for 3/4 pi. Now right here, rotating to 5/4 pi, that's a fourth past pi, we can see that we've got negative square root of 2 over 2 as the x and negative square root of 2 over 2 as the y. And right here, that is going to give us 1 as the ratio for tan. Finally, right here, rotating to the last half quadrant rotation, we've got 7 over 4 pi, which is positive square root of 2 over 2 for the x and negative square root of 2 over 2 for the y. And right here we can say that negative square root of 2 over 2 divided by positive square root of 2 over 2 is going to give us a -1 for the ratio of tan, right? So we can kind of see what's happening with these ratio values in between the vertical asymptotes a little bit. And what we're going to do now is go ahead and take a look at a graph of this with our program. All right, guys, so right here we are on our unit circle, and we've got the ratio of tan as y over x. We start out with 0 radians, and we have a y value of 0 and an x value of 1, giving us our 0, landing us right on the origin there. As we rotate through the first quadrant, what we're going to see is the x values decrease and the y values increase, right? So basically right here, rotating through the first quadrant, we're going to see the x values and y values come to the same value at the half quadrant rotation, and then as we rotate past that, the y values are going to get greater than the x values, and the x values are going to go to 0. So we can see ourselves coming into that vertical asymptote, and basically right here what we can see is we're going to be increasing into that vertical asymptote. So we start out with smaller y values and greater x values, giving us positive ratios less than 1. Then at the half quadrant rotation, we see the x value and y value as the same, right? Approximately right there. And then as we rotate past the half quadrant rotation, now y values are getting greater than x values, and x values are going to 0, and we can see the graph of tan go up to positive infinity, right? So that's the first quadrant of rotation there. Now rotating into the second quadrant, we're going to have negative x values. So our ratios are going to be negative at this point. And right here what we can say is, as we rotate through the second quadrant, we're going to start out with x values that are very small negative numbers and y values that are numbers just less than 1, right? As we rotate through the second quadrant, we're going to see the y values become less and less positive, and the x values become more and more negative. And basically right here, the x value and y value are going to be corresponding positive and negative numbers at a rotation that is the half quadrant rotation of 3/4 pi. Now rotating past 3/4 pi, we see the y values become less than the x values, and we're going to see those ratios become very, very small numbers as we head towards 0 at pi radians. And right here at pi radians, we have, of course, the x value of -1 and the y value of 0. Rotating through the fourth quadrant, now x values and y values are negative. So that means that the ratio of tan is going to be positive, since two negatives are going to cancel out. Right here, just like the first quadrant, we start out with small y values and x values that are just less than 1. So right here we'll start out with fractions that are basically numbers less than 1 until we get to the half quadrant rotation of 7/4 pi, where the x value and the y value are equal, giving us 1. And then after we rotate past that, the y values become greater than the x values, and the x values go to 0 as we rotate towards 3/2 pi, giving us a vertical asymptote at 3/2 pi. Now rotating finally through that last quadrant, we can again see the x values, now very small positive numbers, and the y values as negative numbers just less than 1 first. And then as we rotate through that fourth quadrant, we are going to come to the half quadrant rotation where x values and y values are equal. And then after that, the x values become greater than the y values, and the y values go to 0, giving us small negative numbers going to our 0 at the end of the quadrant, right? So we're going to go back through and look at an analysis of this function. Just like all the trig functions, since as we rotate around and around, we cycle through the same x values and y values, we can say that tan is, of course, a cyclic function. So the pattern we're seeing here just repeats, right? We basically see an increasing function between vertical asymptotes for the graph of tan, right? Where those vertical asymptotes happen at rotations that land us on the y-axis, which are going to be rotation values of 1/2 pi plus a k integer increment of pi, right? So right here what we're going to do is a quick analysis and then talk about the period length. For the graph of tangent, we can say the domain is going to be all real numbers except for those rotations that land us on the y-axis, and those are going to be rotations that are equal to pi over 2 plus some integer increment of pi, just like the rotation values for secant, right? So right here, The range is going to be all real numbers, since the tan function is basically coming from negative infinity and going up to positive infinity in between each of its vertical asymptotes. We can say it's an odd function. It has no extrema, no peaks or valleys to this function, and the asymptotes are basically the rotation values landing us on the y-axis that we already outlined above. Now, what did I miss? I did not write my k is an element of the integers, right? Okay. Now right here, in general, we can say that the tan functions period is going to look like this. It's going to start at 0, then it's going to go into a vertical asymptote, then it's going to have a 0 at the halfway point, then back into a vertical asymptote at the 3/4 rotation, and then right here it's going to end at 0. And the one thing we can say about the tan function that sort of differentiates it or gives us an idea of what we're seeing is it's increasing. It's constantly increasing. So we start out at 0, we increase into our vertical asymptote, and then we increase from negative infinity up to 0 at the halfway point, and then we increase from 0 to positive infinity in our second vertical asymptote, and then finally we increase from negative infinity back to 0 at the end of the period. So right here, what I want you guys to do is to take a quick look at the cotan function. And right here, for the cotan function, we're going to do basically the same thing that we did for tan. We're going to go around the unit circle and look at rotations that are quarter rotations, right, for cotan. And then we're going to go through and look at half quadrant rotations and see if we can come up with an idea of what we're going to see for the graph of cotan. At that point, what I would say is it's a little complicated to think about the relationship between x and y values as we rotate through these quadrants, but you're actually going to have enough information, I think, with the quarter rotations and the half quadrant rotations to sketch out a graph of cotan. So why don't you guys go ahead and give this one a shot, and we'll come back and look at it in a second.
All right, guys, so let's look at this graph. So right here, we start out with a rotation of 0 radians, and at 0 radians, we have our x to y as 1 divided by 0. So of course, right here, we're actually starting with a vertical asymptote, right? Now, as we rotate through the first quadrant, we're going to see that same decrease in x values and increase in y values. In the first quadrant, we're going to be starting out with very small y values, dividing x values close to 1, and that means that we're going to be coming from positive infinity with our vertical asymptote. And as we rotate through to the half quadrant rotation, we can see that we are heading towards 1. And then rotating past the half quadrant rotation, now we're seeing y values go to 1 while x values go to 0, giving us 0 over 1 for a rotation of pi over 2. Rotating through the second quadrant, we're going to start with very small negative x values being divided by y values close to 1. And so those are going to give us small negative numbers. And those small negative numbers are going to get more and more negative as the x values increase and the y values decrease to our half quadrant rotation, where we have the corresponding positive and negative square root of 2 over 2 for that half quadrant rotation at 3/4 pi. Now when we rotate past that, as we rotate past that, we see the x values get more negative as the y values go to 0, taking us down to negative infinity. Now again, when we rotate in the third quadrant, we have negative x and negative y, so that means the cotan ratio is going to be positive. So right here we have a vertical asymptote at pi, and we're coming out of that vertical asymptote with positive cotan values, where we have very small negative y values dividing x values close to negative 1. As we rotate through that third quadrant, we're seeing the x values become less and less negative as the y values become more and more negative until we get them equal. Now rotating the rest of the way through the third quadrant, we can see the y values going to negative 1 as the x values go to 0, and that takes us to 0 at 3/2 pi. Now right here, I'm going to have to move this graph over. Finally, in this last quadrant of rotation, we're going to start out with very small x values that are positive being divided by negative y values close to 1. And right here, as we rotate through that fourth quadrant, we're seeing those negative y values become less and less negative as the x values become more and more positive till they're equal or corresponding positive and negative values at a rotation of 7/4 pi. And then finally, as we rotate the rest of the way through that fourth quadrant, we see the x values go to 1 as the y values go to 0. And right here, that takes us into a vertical asymptote at the end of our full rotation.
All right, guys, so looking at this graph, we can basically see a function that is decreasing between its vertical asymptotes. If we're analyzing cotan, we can say that we have a function that has a domain of all real numbers except for the integer increments of pi, and those are the rotations that land us on the x-axis, where we're going to have a y value of 0, meaning we're going to have a y value in the denominator of our ratio there, giving us our vertical asymptotes. We'd say the range of this function would be negative infinity to positive infinity. This function is an odd function. It's symmetric with respect to the origin. It is unbounded. We have no extrema, just like before. And right here, we have asymptotes basically at those integer increments of pi, right? Now right here, if we're breaking down the period of cotan, we're basically going to see the sort of same, not quite helpful information that we saw from tan, right? We started a vertical asymptote. At our first quarter, we have a 0. Then we go into a vertical asymptote at the halfway point. Our third quarter gives us a 0 again. And finally, at the end of our period, we're seeing a vertical asymptote. The thing that's going to distinguish cotan is that it is decreasing, constantly decreasing. So we're decreasing from that vertical asymptote to 0, then we're decreasing into our next vertical asymptote, then we're decreasing from positive infinity to 0 again at our 3/4 point, and then right here we're decreasing into the vertical asymptote at the end. And of course what we're seeing with cotan is the same thing we've seen from all of our trig functions. We have cyclic functions here. So this pattern that we're seeing with cotan just repeats over and over and over again. All right, guys, so we will work on graphing some of these functions in class tomorrow, and I will see you then.